Hello and welcome to the fourth video in this new tutorial series on Java 8 for the channel. I've made a few changes to the layout of the development environment to support smaller screens and lower resolutions. Hopefully this helps those who are having issues with the prior videos. Today we'll take a quick look at method references, when and where they're valid, and how to use them in a Java 8 context. So the first thing to know about method references is that there are two types that look exactly the same from a coding standpoint. There are static method references and there are instanced method references. And we'll get to the difference between those two types in a moment, but it's important to keep in mind that there are two types that look the same. The syntax for each of these is still going to be class name ::, method name. And in order to reach that point, we need to know where exactly method references are valid. And method references are valid anywhere a lambda function can be used. They can be thought of, although it's very slightly different from a lambda expression internally, they can be thought of as syntactic sugar for lambda expressions, or at least for a particular type of lambda expressions. So we might want to spell this correctly. There we go. Now, what is the difference between a static and an instanced method reference? In order to discern that, we're going to need to build an instance class here just to get the point across for us. And we'll go ahead and make that class point. And in this class point, we're going to have int x, int y, excuse me, and a constructor. And that constructor will just equals y. And we're going to want two different types of methods in here just to discern the difference as far as how the static and instanced method references can be used. So we're going to have one public static method that returns a point, which is called xeqy point. And it's going to take in one integer, x, and it's going to return a new point, xx. We're also going to have an instance method, public transpose, or void rather, void transpose. And all this is going to do is swap our x. So t equals x, x equals y, y equals t. Yes. Excuse me. And just for our own purposes, I think, yes, okay. For our own purposes, we're going to go ahead and override. So this is an instance method, but it's inherited from object, so it's not going to prevent us from using it as a functional interface if we want to. That's not really going to matter in this episode, but it will matter in future episodes. So public string to string, and we're just going to want to build this string builder, and we're going to want open parent x comma space y and close parent and toString, of course. All right, and that'll just sit there for the moment, but that's going to be our point class for this and future videos. We can go ahead and remove this, as well as these, though we will bring them back in a moment. We have a nice clean environment to start with. So what do we want to do first? Well, the first thing we want to do is look at a static method reference. And for the static method reference, of course, we're going to use the x equal y point. Excuse me. So public static void. Oops. already have that. System dot out dot print line, and we are going to take an int stream, and of course we're going to use our general range we use for everything else is 0 to 10, and then we will map to object. All right, a lot of that got covered up by some of the stuff. So instream.range, map to object. And our mapping function here is going to be point x eq y point. This is our static method reference. Now this isn't going to be available yet, but the way that you can think of this particular method reference, a static reference, is you have an input, I, and then you input y as the argument to the static reference x equal y point. And we'll want that way. So those two lines are equivalent. We'll go ahead and put them below each other so they can be more easily discerned. X eq y point I. And we can remove these. Now this isn't going to be valid, as you can see. We'll just comment out both of these lines for the moment. But the point is that these two lines are equivalent. And when you use a static method reference, this is effectively what you're getting out. So go ahead and uncomment this, and leave that line commented. Strange behavior on the tabs here. I'm unsure of why, but that's fine. So after we map it, we are going to go ahead and collect it, and from what we discovered last time, we can just do a toList. And I think this will be fine. So I'm pretty sure it'll go ahead and call to string whenever it prints the list, but let's make sure. Yes, that's exactly what it does. Okay, so here we have our x equal y point, and it's all been generated through this static method reference. Now let's go ahead and look at a dynamic option, and we're going to print out two different arrays this time, although it'll be the same array, just printing out different points. So we'll go ahead and say we want a list of points, and boy, okay, that's what's up. Okay, that's why it's having such strange issues. So let's go ahead and put this back. Not kind of all of them out. Okay, that is the correct number. Except we don't have those. Excuse me. Okay, that's much better. So we go ahead and make a list of points called point list. Very creative, I'm sure. And we do our standard here, instream.range 0 to 10. And in this case, put it there, yeah. We want to map it to an object. And we can't really do a method reference here in an easy way, but we'll go ahead and map it like this. So this is an int function which returns the object of a point, and we'll go ahead and do I plus 5. And why are you complaining? Should be fine. Okay. It is fine once I get to here. And we'll do the collectors to list again. And then we will print it. Now there's a reason we made an instance variable here, point list. And that's because we are going to change it. So we'll go ahead and print point list, and let's just make sure that this works exactly as I expect it. And yes, it'll print out our set of points, 0, 5, 1, 6, and so on. So now we're going to use our instance method reference. Now I'm going to do the lambda version first, and then we're going to condense that into a method reference. So point list dot for each, and if you remember what we had in our point, you can tell what method we're about to use here. For each, whoops, strange, why did I do it that way? Okay, and what we're going to do here is I dot transpose. Now it may even tell us here that we can replace it with a method reference. Aha! We'll go ahead and print this out. And this should actually print line. This guy. And we should get, in this instance, 5061. Yes, that's exactly what happened. Now we have this lambda function, and we're going to go ahead and throw it down here, just so we can have our nice comparison. We have for each, and instead, we are just going to do point transpose. So as you can see, we have two different methods, one of which is, well, you don't need the, there we go. We have two different method references which look the same, but one of them is static as one of them is instance. And the static reference applies the static method to the input value, whereas the instanced reference calls the method on that instance. They look the same, but it is important to keep in mind the difference between the two. So that is the basic overview of method references. They should have this and this. They can be very useful in Java, and if you come from a C++ background, then you already have used these constantly as just function pointers. But the way that method references set up are actually quite nice once you start putting them together with the new interfaces, and we will get to that in the next video. Hope you enjoyed. Thank you, and I'll see you next time.